we are creating a new class. So in our package Java lessons, here I'm going to right click on it. Right click on Java lessons, I'll say new, and I choose new class. So I'll give it the class name type conversion. Call it type conversion. Okay, so again I'm gonna move to our new file here. So I'm going to put in the main class. So I'm going to say int, not int. I'm going to say public static void main, public static void main, and then we have string args, then we have the square brackets, then we have the curly braces. So we have our new file. Now let's understand something here. Now when you assign one type of data to another type of a variable, um, automatic conversion will only occur under some conditions. In other words, we say Java is a strong type. Strong type means it's really strict in terms of type. So it also means that does not mean that automatic type conversion, or what we call implicit type conversion, is not happening. It's happening, but it has conditions that allow the automatic type conversion to occur. So for example, if you assign the variable, let's say you say int a, let's show something, you say int a is equal to char b. I want you to see something. If you look here, there's an error, and if you come here, you see there's multiple markers at this line. Syntax error on token char, delete this token. And the second thing says b cannot be resolved to a variable. B cannot be resolved to a variable. Now let's do this. Let's say char a, then we come down, let's say int a, then we come down here and say char b. When you assign one type of data to another type of a variable, that is an int to maybe a float, a boolean to an integer, there is automatic conversion that can happen, and that automatic conversion happens under few conditions. So we say conditions for automatic type conversion. So the first condition is that the two variables needs to be compatible. The two variables needs to be compatible. Now let's look at this. We grouped the data types into 4 groups, and under int we say there is byte, there is char, there is float, there is bool. So let's say, for example, no, not float. We say there is int, there is char, there is byte. Now if I say, for example, byte a, and then I come and say int b, and maybe assign this one to 10. I come and say int c is equal to a plus b. If I drag on this error message, you see the local variable a may not have been initialized, so we have not initialized this to to anything. That's okay. It's no problem. Um, what I want to illustrate here is that uh, we have, or rather, we have byte and we have int. So what we are doing here is we are trying to actually to assign or to use a byte and to use an integer and store all these two values in an integer. We are using a byte and an integer, and we are trying to store all these two values in an integer. So when we talk about an integer and a byte, so we said that the integer variables, we gave them four, we say there are four integer variables in the previous videos. And when we're talking about four integer variables, we mean in the group of integers we have four variables. We have four, four, not variables, four types. And when we talk about four types in the integer variable, we simply mean that those types that are numbers, yeah, those types that are signed and unsigned, signed and unsigned positive numbers. That is what we actually talked about. And it's very essential for us to understand that we said the int is 32-bit. That's what we said. And for the byte, we said the byte is 8-bit. So if we say C, we say, for example, A, let's come here and say A is equal to B. A is equal to B. And let's check this error. A is equal to B. You see there is type mismatch. So it says it cannot convert from int to byte. Why? Because the first condition is that the two variables needs to be compatible. So are they compatible? Yes, they are compatible. But what we are trying to do is we are taking a byte, we are taking an integer which is 64-bit. An integer which is actually bigger than a byte, and then we are trying to store a bigger thing into a smaller thing, because a byte is 8 bits. Yeah, so we need to really understand an integer is 32 bits and a byte is actually 8 bits. So we are trying to store 32 bits inside 8 bits. Now that's definitely impossible, because it's a larger, we are trying to fit a larger container to a smaller one. Now let's do another one here. Let's say B is equal to A, and then we put that. Say B is equal to A. Now you see B is equal to A is not giving us any error. B is equal to A is not giving us any error. Why? Because B is integer, which is 32-bit. You need to remember that integer is 32 bits, and then byte is 8 bits. So if we are trying to fit 8 bits into 32 bits, that's possible, right? That is possible. So you see here, B is equal to A is not giving us any error. It's not showing us any error. Why? Because B is bigger than A. So that gives us the other condition. That is condition number 2. Condition number 2 means we are saying the destination type is larger than the source type. The destination type is larger. Destination larger than the source. Larger than the source. Now, if you look at this example here, we are converting byte to integer. So byte is the source, then integer is the destination. So the destination here, integer, is 32 bits and the source byte is 8 bits. So that's why we are not getting any error, because the destination is larger than the source. So type conversion, implicit type conversion can take place. Now the third condition is actually it's a general thing that we need to know, is that the character and booleans are not compatible to each other. You cannot convert from character to boolean, cannot convert from boolean to character. That's a general condition. The major conditions are these two here. You make sure that the variables that you want to have, I mean the variables for the implicit conversion to take place, the variables should be compatible. Number two, the destination should be larger than the source Now the question could be, or you would be asking yourself, so what if we have a scenario where we want to force a larger variable into a smaller one. We want to force a larger variable into a smaller one. So in other words, we want to store, we want to actually assign incompatible types. So that takes us to another concept called casting incompatible compatible types. Casting incompatible types. So we only use casting when we want to create a conversion between variables that are incompatible. Okay, so this is an explicit type of conversion. We are actually doing it as programmers. It's not done by Java. We are doing it as programmer. So it is the explicit. What Java does is implicit, and we have talked about the two conditions for that to happen. So this is explicit. So the explicit has the general formula. This way, we need to have the target type, then followed by the value. The target type followed by the value. Now, let's look at an example here. So we say int a, and then we say byte b. We say int a and we say byte b. I want to notice that it's possible to assign byte into integer because byte is smaller, but integer is bigger. Byte is 8 bits, integer is 32 bits. But it is impossible to assign integer into the byte implicitly, so we have to do that explicitly. So to do casting for this, we can simply say b is equal to, then we need to have the target type. We want to convert b, which is a byte, into we want to convert a, which is a byte, which is an integer, into a byte so that it can fit into b. So we need to indicate the target. So the target type is byte in those brackets. Then outside those brackets, we need to indicate the variable, which is a. We need to indicate the variable which is actually a. We need to indicate the variable which is which is a. Now, so we have int a, we have byte b, and we say b is equal to okay, let's see what this error is about. The local variable a may not have been initialized. Yeah, so this error is about initialization, not about type mismatch. So you can see this type has really this type. Okay, we can just initialize this one so that we remove the error. So we say is equal to 9. Now the error disappears. So b is equal to byte, then a. So in other words, we are saying take a, which is an integer. Now we are converting it explicitly to byte, then we store it in b, which is actually a byte. That's how we do explicit conversion. So you have the target type in these brackets, then you have the value. So when a floating point value is actually assigned to an integer type, we have to make we have to risk the fractional component of that floating point value. In other words, it is truncated. So if I say something like just do another example down here. I say byte a, and I give it the value of 40. Then I say byte b, and I give it the value of 50. Then I say don't worry, I'm going to erase the other parts. Then I say byte c, and I give it the value of 100. Then let me delete these ones here so that we can comfortably use them. So again, we say now we want to have an integer, so an integer d. So how we get D means we take A, for example, we multiply A by B, that is 50 by 40 by 50, then we divide by C. Now the resultant of this particular operation, this one, is actually a decimal point. Okay, because B will be divided by C. B will be divided by C. In other words, 50 over 100 is going to be 0.2, right? Am I right? Yeah, by 5, 1, 1, yeah, 0.5, yeah. Then 0.5 will be multiplied by 40. Simple math, that will be what? 0.5. If we multiply 0.5 by 40, we get a whole number. I want us to be getting I want us to have an operation that gives us okay. So we can just have let's do this. We can put this. Let's force something. Put that in brackets. Let's force. I'll talk about this what I'm doing later. So let's put that in brackets. So we want to have A multiplied by B, that is going to be 2000 divided by 100. So let's make this 4. Let's make this 4 instead. So we get 200 and 200 divided by 100 is 2. Let's make it 2. Even let's make it 1, so that we get a decimal value. Okay. So just want to show you something. If we print this, let me try to show you. If we print this, system dot out dot print ln. Now here I'm printing D. Let me print D. Let's see what is happening. Let me run the program. Let me run the program that we check the output. So you see there is 0. Okay, why is it 0? A times B is 50. 50 divided by 100. 50 divided by 100 is what? 0.5. Yeah, 0.5. So 0.5, the 5 is actually truncated. The 5 is removed. The 5 is removed. Yeah, here. The 5 is truncated and our output shows 0. That's what I mean. So when you have Boolean values, when you put a floating point value, you assign it to an integer type, then the fractional component is going to be lost. So it's important for us to understand that. So as a solution to the problem, to this particular problem of having or losing the fractional components, Java does an automatic promotion of each byte, each short, and each character variables into int when expressions are evaluated. So when Java is evaluating an expression like this one, if there is any byte in that expression, it will be promoted to int. If there is any short, it will be promoted to int. If there is any char, it will be promoted to int during evaluation. So this is simply to avoid the truncation, or to solve the problem of truncation. So so when you come to, for example, if you check this, let me just do another example. So we have byte B, we have B already. So if I say something like B, I reassign B and I say B is equal to B times 2. Let me just show you something. So I say B is equal to B times 2. Now I want you to see B here is a byte, and I've given it the value of 50. Then I say B is equal to B times 2. This will give you an error. You look here, type mismatch, cannot convert from int to byte. Now the reason as to why it is giving you an error, right? And it's because this operation here, B multiplied by 2, is now int. Okay, it is now int. It has been promoted. B has been promoted to int. So we are now trying to store int, because the results of b multiplied by 2 is promoted to int. So we are trying to store int in a byte, which is not possible if we are not going to use the explicit type casting. Reason is because int is bigger than a byte. But in real sense, just see here, we multiplied a byte by 2, so means we should be getting a byte. Yeah, but instead we are getting an integer, and it is telling us type mismatch. Why? Because the byte in this operation is automatically promoted to integer by Java. Java does that automatically. So I hope that is clear. Now, there are rules that Java uses to do what we call type promotion. There are rules that Java uses to do type promotion. Remember, we've said that a character, short, and byte, when in an expression, Java automatically promotes them to int, and we have seen that practically. So there are rules for Java to actually do that promotion. There are rules Java follows, and the first rule is that all byte, all short, and all character values are promoted to int. I have mentioned that the byte, the short, and character values are promoted to int. Number two, if we have one operand that is a long, the whole expression is going to be promoted to long. If one operand is long, then we have the whole expression promoted to long. If one operand is float, the entire expression will be promoted to float. And if any of the operands that we actually have there are double, then the results are going to be double. So that's all about casting. I hope you've seen why we need casting. Why is it important to have casting? So I'll stop there for this lesson. I'll meet you in the next lesson. We are going to talk about arrays. Yeah.